ओके। हेलो एवरीवन। तो लेट्स स्टार्ट। आज का टॉपिक है हमारा फैच डिकोड एग्जीक्यूट साइकिल। ये कैसे काम करता है और जो बसेस होती हैं वो कैसे इन्वॉल्व होती हैं, हाउ द डेटा एंड सिग्नल्स आर ट्रांसमिटेड डिफरेंट डिफरेंट कंपोनेंट्स ऑफ द सीपीयू एंड द रैम, रैंडम एक्सेस मेमोरी और मेमोरी। सो if you have not seen the previous video, then you have to go back and get the concepts very clear. That's about the purpose of the components in a CPU, right? Previous video आप चेक कर लीजिएगा, उसमें एक एक जो रजिस्टर्स है विच इज द पार्ट ऑफ द सीपीयू, उसमें डिटेल से बताया हुआ है। ठीक है, सो लेट्स स्टार्ट। यू नो, कंप्यूटर process the data all the time, right? Computer process, this is your PC, right? It processes the data all the time and it gives you output. This is a very simple concept, right? But for this, computer has to follow your PC, your computer has to follow a series of steps or instructions. And technically, we call it a computer program. Is that clear, boys and girls? Your computer, it follows a series of steps or instructions, and we call it a computer program. It happens all the time. Computer, it means computer fetches the data or instruction, it decode the data, and then it execute the data. So this process happens billions of times, billions of times in a second. Clear? Any question? Okay. So, in the previous video, I told you about the relation between the CPU and the random access memory, or it's your memory, right? So CPU directly accesses the data from the main memory, right? It has a direct access. So that's why your computer works very fast, but it's not faster than the registers. That is the internal part of the CPU. Clear? So let's start the main topic, which is fetch, decode, execute cycle. Okay, so I'll take some time to make this diagram because that will clear your concepts, right? So that is your, so it will let me save the time. So let me make it from my pen stylus. So that's these are the registers, program counter register, right? And this is MAR register, memory address register, right? And we have then MDR register, memory data register. Okay. Then we have a very important part of the CPU, that is control unit. It's control unit, and we have accumulator, A double C R accumulator. Uh, that is your ALU, arithmetic logic unit, which performs all the calculation, mathematical and logical. Logical mean all Boolean operations, right? And accumulator is used to store the interim results of the ALU or the processor, right? So we have another register, and that is current instruction register, right? So we have, let me make this one as well. So that is a decode part that make your concept very clear. This is opcode for IG1 and IG2. You don't need to be confused right now, because opcode operand, that is not the part of your syllabus. You just need to remember decode and execute, fetch, decode, execute. So that is instruction, right? So say for example, we have, this is internal structure of the CPU, and ये मैं अभी रैम भी बना लेता हूँ. It's main memory or memory, right? So it has address and it has data. So let's start. What happens? Oh, sorry. We have to, let me place some data as well so that you can understand. This is an address, and let's say we have a random data 0, 1, 0, 1, 0, 1 and 0, 1. So let me place some data over here. This is one address number 2, and this is address number 3, and this is address number 4, and we have 5, and we have 6, etc., etc., right? So we have 00010100. Then we have 0011. It's a random data, right? So 3 we have, it can be, it cannot be duplicated. 1001010, and it's 0000 and 0001, and let make it 11. Now we have 1, 2, 3, 4, 5, 6. Then we have 1, 1. Okay, let's make it 111. Okay, we have 0011002468. Okay, if you can see, this is the data. It's a 8-bit register. It can be 16-bit. It's more than that, by the way. In practically, we have a long address, but यहाँ पर we don't have time, so इसे मैंने कम लिखा है, ठीक है? So what happens? We have the data. Let me complete this as well. This is decode part in the CPU. So we have different data It's a messy, but you have to understand it, right? Double zero, double zero, double zero, double zero, and instruction can be anything. So let's start. That's enough, I guess. So we'll complete the decode part later on. PC program counter register, program counter register, it holds the address of the next instruction to be executed, right? So, so let's take this example of double zero, double zero, right? Double zeros, double zero. For example, PC has this address double zero, double zero, right? And it sends this address to the MAR. Now, MAR, it's a register which knows the location of this address. You got my point? But this is the address. So this address is copied into the memory address register. Now, MAR, this register knows the location of this address, which is this one, right? So MAR, it sends the data mean the address through address bus, right? It's a address bus, right? So this data is sent to the main memory. Now, what happens next? So control, it waits for what? Now control units make sure what is happening. Either the data is going to be read from the memory or write. What should be the operation? So control unit sends a signal to read the data. So this is the address and this is the data or instruction. So now the operation is to read the data from the memory. And what is the data against this address double zero double zero? That is 01010101, right? So this data will be transmitted or traveled from your main memory to MDR register. Is that clear? So this data will be transmitted through data bus, and you know the type of this symbol, the arrow, it's a bidirectional, and control bus, that is also control bus, that is also bidirectional. So this data double zero double zero, sorry, this one 01 01 01 01 and 01. Now this data is copied into the MDR register. Is that clear? Any question? Okay. So the data is transmitted from memory to MDR. Now MDR copy this data to CIR register, that is current instruction register, right? So this instruction is copied over here at CIR. That is the place where the data is decoded, right? At this point. Technically, at this point, after the data is copied into the CIR, the fetch stage is completed. You got the point? Now, this data is copied into CIR 01 01 01 01. Now, for again IG1, IG2 beta, but you have to just understand कि यहाँ पर decode होता है, then execute होता है, right? For IG3 and AS students, you have to understand the concept now. And what is that? Remember that beta, this is an instruction 01010101, and instruction set that is composed of opcode and operand. This is the opcode, operation code, and this is the operand. Operand mean it can be a address where to find the data, or it can be a data, right? Opcode mean for A students, if you can recall your memory, remember that CPU fundamental, we had these things, we have activities and the concept of CPU fundamental, how it works. So we have different commands over here. Opcode, we have the addresses, then in operand, we have different addresses of the register and so on, right? So opcode, load, jump, JPN, JPE, remember index register, LDD. So these are the commands, right? For IG student, you just need to remember that this instruction is decoded over here, right? Now coming back to the point, decode. So that is this one, that is the opcode 0101. Now CPU look into this decode part and it find out 0101. Where is that 010? So I didn't write it. So let's say this is 0101, and the instruction is that is about to load. Load what? This is address. In instruction that is load, and this in operand I have written this address, AD address, and this is the opcode 0101, right? So now this is the decoding part we have done. Now this data is supposed to be completed or executed. देखिए अभी complete नहीं हुआ, right? So what happens now? 0101, this is the opcode. It find out the address. This is 0101. Okay, ठीक हो गया है. तो what is the instruction? ये जो 0101 पे डेटा पड़ा हुआ है, where is that? This one in memory 0101. ये वाला जो कंटेंट्स एड्रेस पे, इस एड्रेस पर ये जो कंटेंट्स डेटा पड़ा हुआ है, इट शुड बी copied into accumulator. So what happens now? This address which is 0101, that will be copied to the MAR again, so that the final stage, which is execution stage, that is to be completed or finalized, right? So this data address 0101, that is transmitted through address bus to the memory, and it find out the address. Again, now CU control unit find out what is happening is that requires a read operation or write operation. So again, it's a read function. So control unit sends the read signal to the memory. So that is the address 00000011. So that will be copied to again 000011. That will be copied to MDR. Then from MDR to accumulator. Right? Now the data is placed over here, that is 00000011. So here the fetch decode, execute, cycle, ends. This is a complete cycle, right? Here, how the buses involved in this cycle and how the data instruction is decoded, right? So there is only one example I told you about: load the data from memory to accumulator register. And there are so many commands, just like store the data, store the data, or performing a calculation. In execution part, again, I'm repeating, in execution part, the instruction is carried out. This could be like going back to main memory, just like it happens here, and fetching the data, जो कि अभी हुआ है, fetch हुआ है. It can perform a calculation. Okay, ये भी हो सकता है in execution stage. Number 3, storing information back in memory. ये भी हो सकता है कि the data can be written over here. For example, this is an address. तो यहाँ पे the data can be placed over here. यहाँ पर भी लिखा जा सकता है data, right? So that only depends on the instruction. Data may end up being copied into the ALU or accumulator, or writing the data into the memory. Clear? So another thing, now let me labels that control unit, it's control everything. The white, no, I should choose this, the light blue. So control unit controls this one, MDR, this one, this one, and कि accumulator और ALU, यहाँ पे ये क्या होता है, डायरेक्टली, ये यहाँ पर बाई डायरेक्शनल काम होता है. डेटा कैन बी ट्रांसमिटेड बिटवीन दिस because accumulator is the part of the ALU, right? So control unit, it can control this one. Sorry, I used the green one. So that is controlling unit is also controlling this, and it's a messy. So you just have to understand this, right? And CIR, that is CIR, that is connected with this part. And okay, CIR fetch cycle, we are done. Another thing, that is the last point. Beta, at this stage, when the fetch cycles completes, the PC, which is program counter registered, that should be incremented by 1, which means now the address is 0000. I gave you the example. Now it is done. So it should move on the next instruction, next address, which is 000001. So the PC should be incremented by 1. It should move on to the next address, which is now 0001. Again, the same process happens. This 0001 address will be copied into the MAR by using address bus, unidirectional bus. It sends this data and waits for the from the control unit and get the signals. Either it's a reading the data or writing the data into the memory, right? So the same procedure happens, same process happens. If anything left, so I believe that we have done everything. Let me see the diagram again. Program counter register, MAR, control unit is controlling everything. Okay. CIR, that's fine. CIR से data आपका decoding unit. accumulator, it's a registers that is very much faster. All these registers are very much faster than your memory, right? So let me tell you another thing. So there is another component inside the CPU that is called cache, a cache, whatever you want to pronounce, that is cache, right? So that is the place, that is the place, the memory where CPU fetches the data. Frequently accessed data is placed over here. CPU doesn't need to go back to the random access memory. It only places that data which is frequently accessed by the CPU. So it saves the time. So MAR, MDR, it's a messy, but I believe कि आपको समझ आ गया होगा. That clears your concept. That's all for today, boys and girls. If there is any question, you can ask me. So let's end up. Okay, see you. Thank you. Bye bye.